to do a visual inspection of the data. So let me just do that. Okay. Now these are the data which I have taken from sheet number 1, where I had randomized these observations, and now I have copied and pasted them onto the sheet which I have named as graphs. So I have 30 observations, and then the variables are observation number, respondent ID. So first 3 columns are just nominal because they are just indicating the same numbers. And then except for the RID, because I had randomized the data. So I had selected, this second subject, and then below that third subject, fifth subject. So first and fourth were filtered out because of randomization process. So out of 100 odd numbers, I had selected randomly only 30. And then sex, age, and income. Now let us see, for example, these statistics are there down below. And suppose, first of all, I want to find out, let's say, gender-wise, sex-wise, how, the males and females, how many males are there, how many females are there. So I have already counted them in the previous sheet. We had seen that. And these values are here. Male, 11, female, 19. Now what I want to plot them. I want to show them graphically. So the procedure is very simple. I have these data and I select these two. And then I go to insert. I go to insert at the top. And here I can see various charts. So if I go to the charts window, I see here a pie diagram. Normally, if you have frequencies, you show them in a pie diagram. And the moment I select the pie diagram, I get it. I get this figure where you can see that chart title I can change. If I want, I can change the chart title. I can give my chart title. So I can write frequencies, or if I am talking about frequencies or whatever, that I'll write. So I'll say distribution of, or gender-wise distribution of respondents. You can select a good name. Gender-wise distribution of respondents. I can give a title. Already the legends are there, male and female. Males are in blue color, females are in red colors. Males are less in number compared to females, so it covers a larger area. Now if I right click this window, then I'll see that there's a plus sign here. On the right side, it says chart elements. I can add certain chart elements. So I left click the plus sign and it says chart title. It is tick marked. It's already there. Legends are there, male and female. Data labels are not there. So I also select data labels, and immediately you see that these numbers 11 and 19 come inside the diagram. That means 11 blue is male, 11 males, and 19. If I go again to the right area and select plus, when I go to data labels, I see an arrow pointing toward the right. So I select that and it says, where do I want the numbers? Center or inside? So if I say center, it will shift it to center. If I say inside end, it will shift to inside ends toward the periphery. Outside end, now it has printed the numbers outside. Best fit, it will find out what is the best fit for this particular diagram. Data call out, now this is data call out. Data call out means it will give the various particular category name and also the data in percentage. So it says 63% females and 37% males. You can compute percentages by using percentage formula. As I said, count the number of males divided by the total number of respondents multiplied by 100. But here it is automatically giving you this value. And if you want to do something else, there are more options which you can select. This on the right hand side now, a window is opened, format data labels. You can play with this, and with these things you should actually play. You know, कोई कंप्यूटर खराब नहीं होता, कोई कुछ नहीं होता, सब कुछ अच्छा काम करता है, कोई सिस्टम खराब नहीं होता. आप इन सबसे जब तक, unless you will play with them, you will not learn them. You know, playing is important. So now let's see. So this is a simple pie diagram. If we have frequency distribution, you draw a pie diagram, or you can draw a bar diagram. For example, if I want to show what is the age-wise distribution of income, etc., then I can plot a bar diagram. So what I have done is that for males and females, for age and income. Now males, if you go to this part of the screen, which is in row number 40, 41, 42, then you will see that for males and females, age and income mean values are given. So males age is 43.6 and females age is 35.5, and similarly income. So what do? I can select the data and I go to insert and I go to bar diagram. So I select the bar diagram and I do this. And the moment I select the bar diagram, you see that this figure comes out. Again, suppose I do that. Again, there will be, if you go into this window, so I made it a bit larger for you. It's very large now. So again, there will be a plus sign on the right hand side. And if you select that, again, there will be axes. Axis means you can introduce axes. So I say, yes, I want axes. Axis titles. If I select axis titles, it will give me that small area where I can write the names of the titles. So now if I tick mark that, you see these axis titles come here. On the left hand side, there's an axis title. So I write, you know, age and income or whatever on the vertical axis, and on the horizontal axis, I write whatever is the age and income here, and there I write frequencies on the vertical axis. So frequencies are there, and you know, or mean values are there because I have taken the mean. Then you can keep on doing this. You can say, and chart title is there at the top. And then you can say data labels if you want. If you say data labels, it will print the values. Mean values have now been printed at the top of each bar. If you want data table below this, sometimes when you want to present your data, say after your thesis and all that, and you want to present in one window, then you say data table, and it will print the data table below that. So now it is also printing so just below the bars, you will find that there's a table which has appeared. This table is the same as those values which are for males and females. Error bars. Error bars are the, one quartile. Since we have not gone into the error bars mean the value should fall in this range. So I can plot error bars. The moment I do that, you can now see that with each bar, there's a small, this line, vertical line. And this actually prints one quartile and it gives the confidence interval. We have not talked about confidence interval, but later on I'll touch upon it. If you want to draw a trend line, then you can select that. And for males, okay, now it has given a trend line. Since there are only two categories, therefore obviously this will be a straight line. Otherwise, if you have several categories, you will see a good trend line there. Or you can plot a trend line for the other variable. Say it says linear, exponential, which trend is obvious in your data. You can select that particular trend and you can go to more options. So this is how this curve is, or bar diagrams are plotted. So I have already done that. So I'll send you these Excel sheets so you can play with them. Now there is this, I want to plot income. This window is now showing a scatter diagram. Scatter diagram means how the observations are scattered in a particular range. So let me do it like that so it looks better. So I have plotted a scatter diagram of income with age. How income of each individual is or can be located on this with age. So income is a dependent variable, age is an independent variable. I want to see if income has a linear relationship with age. So again, I select that data, age and income. I select age and income data and I go to insert and I go to scatter diagram. So here is this chart is scatter diagram. Insert scatter X, Y or bubble chart. So I select that and I select the scatter diagram. And the moment I select the scatter diagram, it will introduce the diagram. This is now the diagram that has come. And then again, on the right hand side, you will see a plus sign. You can go to that plus sign. Again, you can say axis titles. Axis titles you can introduce, which I have already introduced in the graph that I'm showing you. Now I'm showing you the process. Axis title, data labels. Data labels you shouldn't select because it will be too cluttered. The graph now you see values appear with every data point. If you want to check, you can check it. For example, for let's say for a respondent whose income is 11, some respondent, this respondent's age is about 19. He is the youngest, he or she is the youngest. I don't know whether he is a male or a female. So you can see that there, where you find on the extreme left, the value 11, this is the youngest. There's nobody younger than, so you go to the youngest. To go to the youngest, you find minimum. Suppose I want to find out the minimum of income. So I write here equal to minimum of, and I go to income, select income, and then I say yes, income is 5. It's so minimum income, you can see that if you look at the vertical diagram, this is 5. Minimum income is 5. Here there's nobody with lesser income than 5. And if you 11 is not actually the minimum is 5. Maximum income is there at the top, and there are 3 persons, or rather one more, 45. So maximum income is 45,000. So suppose instead of that, I find maximum. That is 45. So this, so you can see that this scatter plot is all right, correct. These numbers you can introduce, but then you remove them, basically because it will otherwise create a lot of clutter. So I don't want these numbers, data labels. Again, error bars can be plotted, and grid lines, these grid lines can be disturbing. So I remove grid lines. The moment I remove grid lines, it becomes a plain graph. Then legends can be introduced, legends, income, and then I go to trend line. If I say trend line, the moment I say trend line, it draws the linear fit. So after doing regression analysis, we'll get this fit. Actually, for these data, we'll get this fit. So, and this trend line can be, if I want linear, it will be a linear trend line, and etc. Suppose I say more options, then if I want to insert equation, etc., you can try those things. So in this data representation, I have plotted the linear line, and I have shown that the regression equation is this. It is very small in print, but it says, let me just show you. So the regression equation is y equal to 0.0936x plus 21.836. So 21.836 is called the intercept, and 0.0936 is called the beta weight. Beta weight means there's a coefficient, and in bivariate regression, when you have only one independent and one dependent variable, this is the correlation coefficient, product moment correlation coefficient. And R square equal to 0.0196. This says how good is the model. Model is very poor. It does not explain income by age. R square should be at least, point. In psychology, there's a problem because normally people report that this is the result and R square was this, and they stop there. They really don't go beyond that. They don't, interpret what is the meaning of this. R square simply explains or provides the information that X explains about 2%, because if you multiply by 100, you'll get the R square value to be 1.96. So let's say 2. So here independent variable is explaining only about 2% variation in the income. This is how we interpret. I'll go into this when I do regression analysis, but this is just to show you, how things work and how we should interpret the data.